All right, so yesterday we talked about arithmetic sequences, and today we're going to talk about arithmetic series. And remember that a series is just taking the sequence and adding the terms. So let me go over a few things that we learned yesterday, first of all. For an explicit formula for an arithmetic sequence, this is going to be our formula. A sub n equals the common difference times n plus the zero term, or term zero, the number you'd get if you took the pattern and went backwards from the first term. So that's an explicit formula. The recursive formula for an arithmetic sequence is first you have to say what the first term is. So a sub 1 equals whatever that first term is. And then a sub n is equal to a sub n minus 1 plus the common difference. So for a recursive sequence, you just need to know what the first term is, plug that in here, and know what the common difference is and plug that in for D. For an explicit formula, you need to figure out what the zero term would be and plug that in there and plug in the common difference for D. All right, to find D, if you're not given the sequence, if you're given that the first term is this and the sixth term is that, and you need to find the common difference, the way to find that is take that nth term, say you're given the sixth term, so it'd be the sixth term minus the first term divided by 6 minus 1. So that's a way of finding the common difference. We'll use that especially when we're asked to find the arithmetic means, which are the missing numbers between two, the missing terms between two terms that are known. And then finally, when we have a quadratic, a formula that's not arithmetic, or a sequence that's not arithmetic but is quadratic, we're going to use this formula. A sub n equals a n squared plus b n plus c. And you need to have at least 3 terms of the sequence and use those terms, plug those in. So the first term is equal to a times 1 squared plus b times 1 plus c. And then the second term is equal to a times 2 squared plus b times 2 plus c. And then do that for 3 terms and then solve the system of equations to find a, b, and c. All right, that's what we did yesterday. Now what I want to do is just talk about finding the partial sum of a series. And so to do that, what we're going to do is first find the explicit formula for the sequence, and then we can find the partial sum by just adding up all the terms up to whatever we're asked to find. So let's do number 11 on today's worksheet. We're told to find the 13th partial sum. S13 means the 13th partial sum is equal to, we're to find the 13th partial sum of this sequence, -5, this series, 5 plus 1 plus 7 plus ... up to 67. So we're asked to find the 13th partial sum of that series. All right, so let's first find the explicit formula here. So our common difference, we can see that the common difference is 6. We're adding 6 each time. So the common difference is 6. So we get a sub n equals 6n plus the zero term. So this is the first term, the second term. We're adding 6 to get the next term. So we need to subtract 6 to get the previous term. And that would be -11. So it's going to be 6n minus 11 is going to be our explicit formula. And then to find the 13th partial sum, we're going to plug this into our calculator. N equals 1 up to 13 of 6n minus 11. And then I'll let you find the solution to that, but that's how you set that up. And hopefully you have enough information from what I told you yesterday and what I've given you in this video to finish up this worksheet. If you have questions, please write them down. You can email me with questions. I may or may not email you back right away, but save those questions anyway, and I can answer them when I get back.